Okay, so again, x squared plus y squared equals 25. It's going to say find dy dx. So the derivative of y with respect to x. That's what we're thinking about. Most of the problems that we've always done, they've only had an x in there, or they've only had a y in there, or like the y was already solved for. Does that make sense? Like it was like y equals the square root of x or something like that. Like y was already by itself. So these problems are not. So y is not by itself. Okay, so we're going to use this procedure. It's called implicit differentiation. All right, I can barely say that word, differentiation. I definitely can't spell it, so that's why I put DIFF. Okay, so what we're going to do is we're going to take the derivative with respect to x, okay, of our function here. All right. And again, on this side, what you do to one side, you have to do to the other. So we're going to take derivatives. So we're going back to derivatives right here. I know we've been doing integration forever, so this is a good review. Now, if you do that, okay, this is actually pretty simple. So you can technically distribute this d over dx in. So you have the derivative, all right, dx of x squared plus the derivative with respect to x of y squared, okay, equals the derivative of a constant. The derivative of a number is just 0, okay? So we're good there. Now, the first part, nothing new to us. The derivative with respect to x of x squared is what? It's 2x. Okay. So now is going to come the part that we are not as used to. Okay. So what we're going to do is we're going to take the derivative of y squared, all right, which is 2y. But since this is with respect to x and not respect to y, all right, we're going to also leave on a y prime with this.
Reverse.
Okay. Now, like always, when we did find dy dx and the function was like y equals something, didn't we always get y prime equals something in our derivative? Right? This is what we're still working towards. Okay? We just have to manipulate our equations to get y prime by itself. All right? So I have to isolate y prime and get it by itself. Okay? So all it is going back to algebra 1 and I'm solving an equation. I'm getting y prime exactly alone. So can't I move my 2x over to the other side? All right, when I do that, what happens to it? So you have 2y times y prime equals negative 2x. Now, if I just want to get y prime all alone, what would I need to do next? Divide by 2y, right? So 2y's cancel. We get y prime is equal to negative x over y, right? So that is the derivative. That is dy dx is negative x over y. So again, this problem we're gonna do the exact same way. So we're still taking the derivative of x, all right, like we always do. But now when we have those y's in there, we're gonna have a y prime added into our problem. Okay. So again, I'm gonna write out all the steps that we have. Okay, we have the derivative with respect to x of x to the third, plus the derivative with respect to x of x times y squared, plus, again, the derivative with respect to x of y to the fourth is equal to the derivative with respect to x of 7. Okay, so we have all those things in there now that we're looking at. What we got to do is we got to take each thing piece by piece, because there's 4 pieces. Okay, can we all agree that the derivative of x to the third is just 3x squared? Okay, here on the very end, can we all agree that the derivative of 7 is 0? Derivative of a constant is 0. Are we in agreement on that? Yeah. Okay. Now, on the inside, I'm going to wait on this xy squared for a second. Okay, I'm gonna look at the y. So would y'all agree that's 4y to the third? And then we got to add that y prime in there, right? Okay. Now, do we or do we not have a product rule scenario going on right here, where we have x times y squared? Is that right? Yeah. So we do have a product rule situation going on. So if I take the derivative of the first piece is 1, right? So that's, we got 1 times my second piece, which is y squared. Correct? Plus, now if I take the derivative of that second piece, all right, isn't that 2y times y prime? Times my first piece, which is x. Okay? So let's clean this up a little bit, because that looks kind of nasty right there. All right, that's 3x squared plus a y squared plus a 2xy y prime plus 4y to the third y prime equals 0. Okay? So now our whole goal at the end of this is to try to get y prime, all right, or dy dx. That's what y prime is. Okay, we're trying to get that all alone by itself. Okay? So, immediately I notice there's a couple of things that do not have y prime on them. All right? Those two pieces don't have y prime on them, do they? Okay, so we can move those pieces over to the other side of the equation. Okay? So you know that you're going to have negative 3x squared minus y squared over here. Right? Okay, and you know that that's going to be equal to what we have left. Okay, so here's the pieces that are left in orange right here. Can I go ahead and factor out my y prime? So they have a y prime in common. I'm going to factor that out. Put it outside of my parentheses. So what's left? So 2xy plus 4y to the third. Okay. So now to get y prime by itself, what do we need to do? Couldn't I just divide by this whole term in parentheses? All right, that will get that side to cancel. So we do the same thing over here. 2xy plus 4y to the third. So that's going to give us what y prime actually is. So down here at the bottom, all right, we can say y prime is equal to negative 3x squared minus y squared all over 2xy plus 4y to the third. And that's how you would leave it. That would be our answer. So that's the implicit derivative. I'll be honest, I really don't know what a folium is. All right, the folium of Descartes, but Descartes is a famous math guy out there. All right, so he gets to name it whatever he wants because he's the first one that figured it out, right? So I guess, yeah. So here's your example. It says find y prime if x to the third plus y to the third equals 6xy. Okay? So we're going to go through and do our same process here. Okay? Implicit differentiation. So we got our dx of x to the third plus our dx of y to the third, and then our dx of 6xy. So you got some product rule going there on the end. Okay? So, are we all in agreement on the first derivative of this one? The first piece? What is that first derivative going to go to? Yeah, that one goes to 3x squared.
3y squared, y prime.
Okay, 3y squared, y prime. All right, it's an ugly looking y. Okay, equals. Now, we got some product rule stuff going on over here. So you have first and second piece. So what's the derivative of the first? All right, 6 times y, right? Plus, what's the derivative of the second?
1.
Isn't it 1y prime? So 1 times y prime times my first piece, 6x. Okay, so I have the derivative of the first piece, 6x, is just 6, times the second piece, which is just y. All right. Next, you have the derivative of just y, and that's where we get 1y prime times the derivative of the first piece, which is 6x. Okay, it is a product rule. Okay. All right, on this one. So, again, let's clean this guy up a little bit. 3x squared plus 3y squared y prime equals 6y plus 6x y prime. Right? So what I need to do is I need to get all the y primes on the same side. I need to get everything else on the other side. So I'm going to move 3x squared to the other side, and I'm going to move my 6x y prime to the left side. Okay, so I've got, when I move everything, 3y squared times y prime minus 6x times y prime equals negative 3x squared plus 6y. Okay, now we need to factor out our y prime. So if I factor out my y prime, I get 3y squared minus 6x equals my negative 3x squared plus 6y. And the last step that we got is just divide. So I'm going to divide by what's next to the y prime. So 3y squared minus 6x. And here, nothing will simplify. Nothing will reduce. All right, so we're just going to leave it just like that. Does that make sense? So that would be our answer. Okay?